Okay, we're set and ready to roll. So welcome everyone to the April 11th meeting. Halifax Centre, Royal Astronomical Society. RASC Halifax Centre respectfully acknowledges that we live and observe on the unceded territory of the Mi'kmaq people. RASC believes in and practices inclusivity and diversity. Halifax Centre welcomes all with an interest in astronomy without prejudice. The stars belong to everyone. So the agenda for today, we'll move into the photo montage, and then we've got some member presentations, and there's 4 of them, so we've got a break in the middle. First member presentation is Jeremy Kuzub talking about citizen science and the Aurora, and then Jerry Black and Bob Russell and Peter Hurley and myself will talk about smart telescopes and there some image comparisons. Then we'll have a break, followed by Judy Black talking astronomy humor, and Paul Heath, Sons in the Classroom. Then we'll have outreach opportunities, update from the board, and what's up in April. So on to the photo montage. Okay, so these are images taken last month by RASC Halifax Centre members, and as has been the case since New Year, the skies weren't great for us in March. We had a few clear nights, but the few clear nights we had, there was a big old moon up in the sky too. So this is Jerry Black's Orion and the Running Man Nebula, taken with his Seestar S30 Pro, and as Jerry would say, mangled in Pixinsight. I don't think it's mangled. Looks pretty darn good to me. Michael Bochat, I don't know how he does this. Out of his window, he must have been hanging out the window. He got the very thin crescent, the new moon, on March 19th, just peeking out between the clouds. See the very thin crescent right there. And another one from Michael, solar prominence on March 19th with his Coronado personal solar telescope. You can see this rather large prominence off the limb of the sun. And sunspots on March 28th. Around that time, towards the end of March, we had pretty good sunspot activity on the Earth-facing side of the sun. Barry Burgess caught moonrise on March 2nd. So this would be the full snow blinding moon. And Jeff Donaldson has been dipping his toe into some lunar and planetary imaging. So this is Mare Imbrium and Sinus Iridium. And the Southern Lunar Highlands, also from Jeff. And Jupiter, a mono image of Jupiter with 2 of the Galilean moons being visible. And a deep sky object from Jeff, Messier 46, which is an open cluster. And what's interesting about this particular open cluster is this little planetary nebula nestled in it. The planetary nebula is not part of the open cluster. It just happens to be situated in the line of sight, but it makes for a nice addition to the cluster. And hydrogen alpha image from Jeff of the Flame and Horsehead Nebula. So I imagine once Jeff finishes getting oxygen 3 and sulfur, we'll see a color image. I don't know if anyone got up on 1st of March before dawn. No, not before dawn. It was after sunset. The sky was good and you were looking in the right direction, eastward. You might have caught the SpaceX Falcon 9 launch. So this is Lisa Ann Fleming, her image of the exhaust plume of the Falcon 9 in flight after leaving Cape Canaveral. Image from me of sunspots on March 3rd. And the snow blinding moon on March 3rd as well. This was interesting because of libration exposing some features on the limb of the moon that we don't normally see. So in particular, Mare Marginis, you can see here, Mare Smithy, and Mare Austral.
What did you take the picture with?
I think it was with a 150 millimeter reflector, and the Tube Tech equivalent of an ASI. No, it wouldn't have been 150 mil. It would have been my 80 millimeter refractor with the with my Tube Tech 2600 equivalent camera. So, yeah, I was pretty happy with that. And the partial lunar eclipse on March 3rd, early in the morning. Jerry and Peter and I got up well before dawn, and it was cold. And we went up to the parking lot at the new health center in Bayers Lake, where there's a good western horizon, and took a bunch of pictures. And Jerry, have you posted your videos from?
I think I did at
Yeah.
one point, yeah.
Okay, so have a look at, Jerry got some really good videos with his S30 Pro. This is a combined image of on March 25th. The moon was, it's a first quarter moon. It was very close to Jupiter. So there's Jupiter, and there's the moon. And I got a close-up of the moon using my Dwarf 2. So the combined shot, the moon and Jupiter was with a DSLR and I think a 50 millimeter lens, and then the Dwarf 2 for the close-up. And the M&M double cluster in Perseus. So everyone's familiar with the double cluster in Perseus, but this is another double cluster also in Perseus, which is worth seeking out. So a fairly rich open star cluster here and a sparser open star cluster. I think this is also called the pentagram star cluster. And a comet. Got this in the Eastern Townships on March 29th with the S30 Pro. This is the Comet C25R3. You can see it here. It's brighter now than it was at the end of March, but unfortunately it's getting closer and closer to the eastern horizon. So it's, unless you're out looking over the ocean just before dawn, it's getting harder and harder to catch.
So we can expect 14 Starlinks every 5 minutes?
Oh yeah, there's a lot of trails, Starlink trails there too already. I think I took this image around just after 5 a.m. Eastern Standard Time. 6:09, yeah, 6:09 Atlantic. Blair McDonald, really nice shot of the Cone Nebula and the Christmas tree cluster, again from his driveway in Bedford. This is a Hubble palette, which is pretty unique, I think, for this target. And Chris Turner brought us this shot of the Wizard Nebula. And last but not least, the Beehive cluster from Kathy Walker, M44. And I believe, yeah, that's it for the photo montage. So we'll move on to Jeremy Kuzub.
Good. Well, thank you for the opportunity to present. I guess these are member presentations, and this is the first of 4 today, I think. I've been a member for a few years. I came originally from Ottawa RASC Center, and I want to talk a little bit about a wide field project called Aurora that I've been working on in my spare time. This will take about 15 minutes. Please feel free to ask questions during the slides. And also, I really welcome feedback because I'm kind of new to astronomy, cameras, sensor systems, all that. There's a ton to learn about them, everything from noise floors to lens distortion. I welcome any feedback and ideas because there's so much collective knowledge and wisdom here. So please feel free to speak up and let me know if there's some things you've encountered that you think could be improved. This is a citizen science project, which is what we'll, I guess, talk about in a second. And so definitely I welcome. Aurora, we generally think of Aurora as further up north in what's called the auroral zone, or further south. They're like 2 donuts or 2 crowns sitting over the northern geomagnetic and southern geomagnetic poles, which are an approximation. But when there's a lot of geomagnetic activity, as there has been during the solar maximum, which we've just peaked over, I guess, they'd never know for sure, you do get auroral activity that kind of like wearing a hat that's too big, the aurora kind of slide down the Earth towards the equator as the activity grows. And that means that we can start seeing the aurora here in Halifax. Here's a shot from Rainbow Haven Beach. The parking lot was full because there was a lot of red aurora. Everybody came out on the walkways. It was like a party atmosphere. We could all go see the aurora. And this was a southern arc of red aurora. So it's actually south of even us. So it goes to show, I guess, the aurora isn't just a sort of a northern phenomena or something you'd see in Edmonton or Yellowknife or Alaska. When it's at its peak, it can sometimes make its way down here. It's a statistical thing. And as you saw with the amazing solar images just a few seconds ago, the sun is full of surprises and can give us things like this. There's another one from Martinique Beach. It's a panorama of the galaxy and then also auroral activity looking north over the ponds behind the beach. So you'll see that aurora are interesting in that you can't say, steer my telescope to this object and do an integration over 6 hours to get the best possible signal noise ratio. It's more like bird watching, I guess, or hunting or taking photos of wildlife. You have to take what you see when it comes. Your camera's on a ball tripod, you're swinging it around, and your exposures are generally very short and high ISO. So you're capturing structure, otherwise it smears out. And you can see quite a bit of structure in here as the light or the electrons follow the magnetic field lines down through the magnetosphere, impact in the ionosphere. And the shorter your exposures, the more of that structure you can see. And often people take video of the aurora when they're very active, so even 24 frames a second might not be enough. You're also missing everything behind you, theoretically. And that's really what this project is about. So because I was originally sort of aurora chasing with a rectilinear lens, say an 11 millimeter or 12 millimeter lens on a camera, I found I was composing a picture, making it look nice, taking the picture, but meanwhile there's an amazing amount of stuff happening behind me, so I'd swing the camera around again, and then I'd miss what was behind me that was in front of me a second ago. Or I'd take a time lapse of 50 frames and realize, oh, maybe I should have taken it a little bit to the left, a little bit to the right. I always felt I was missing out the whole picture because the aurora can fill the whole sky. So I sort of took a page from the idea of all-sky cameras, and I thought I'd make a portable all-sky camera that I could bring with me on aurora chases that would give sort of context to any of the artistic pictures you're taking with a narrower field of view lens. And that's really where this project came from. Getting a portable all-sky camera that you could just set up and press a button and it would take your time lapses. When you get home, you offload them. The trouble with time lapses, or as you know, is you get photo sequences with thousands of images, and they might just sit on your hard drive if you don't process them. And another goal was to make sure there was an automated processing pipeline that resulted in these time lapses you see up here, along with some contextual information, some keyograms, so that it was really hands-off. You push a, it's kind of like, I guess, Luke Skywalker, he's got, in his X-Wing, he's got R2-D2 behind him that does all the technical work of calculating, I don't know, hyperspace jumps and navigation and repairing things. I want it to be like that, where it really does all the work for you, almost like maybe those Seestar type telescopes, except very wide angle. This is around my first attempts. I took a Nanook first aid case, which are waterproof, integrated a Sony ZV-E10 or a Canon M100 mirrorless APS-C RGB consumer camera with a Raspberry Pi and a lithium battery. And a few other sensors like GPS to tell you when and where you're taking the pictures, and accelerometers attached to the camera so that you could have a digital bubble level to point it right at the zenith, and even a magnetometer so you could orient it towards local north, because the convention, I guess, for all sky images for Aurora is to have magnetic north facing up, not geographic north. And I took it to Yellowknife, and in Yellowknife I realized the lithium-ion battery, of course, freeze at -35. And they don't actually freeze, but I think power banks now are getting too smart. They have, I saw something where somebody had Doom playing on the microcontroller of a battery. So it's obviously way too much processing power in these things. And it had a temperature safety cutoff in it. So even though the battery would still provide power to the whole system, it said, no, this might be a bit too cold. We're entering a range where there's risk, so we'll just shut down the whole thing. So I quickly went to the Canadian Tire and Yellowknife and lined it with some of that bubble wrap, foil bubble wrap that you use around piping. And that helped a little bit. So it's kind of a first or second iteration of what I was learning on how to deploy these in very cold conditions. One thing I noticed, there was a ton of wiring, so I tried KiCad. I don't know if anybody's used that. It's a open source, kind of like Blender or GIMP or anything like that for image processing and 3D work, except it's open source for doing circuit boards, and you can get these made by vendors where you just send the files and you get back the boards. And this one took care of having terminal blocks and routing and power management for all the different sensors I was working with, instead of doing really painful point-to-point wiring. So I thought maybe other people would like to try these rather than just me. Some other people expressed interest. And these were Aurora chasers too. They're already going out to photograph Aurora. They already lived in places where they could see them very well, places like Alaska or Manitoba, even New Zealand recently. And so I thought, well, since it's really hands-off and it's a standardized piece of equipment, maybe we could kind of get a network going. And so that's where the citizen science aspect comes in. The project is to leverage their enthusiasm and know-how of the Aurora. And Aurora chasers are, I guess, a bit like tornado chasers or extreme weather chasers, or anybody where geographic knowledge really matters. The Aurora seem to vary when they show up, how they behave geographically. And maybe that's because of the way the magnetic fields are, where they are in relation to the Earth's magnetic field. But they know their local stuff. For example, they're not going to put it out when it's fully cloudy. So instead of having something that's placed out with an acrylic dome on it that's weatherproofed for weeks and months, they only take it out when they go out shooting, and that means they're probably only going to go out shooting when there's good aurora. So the hit rate of good quality time lapses goes up by letting them take it out. And again, because it's simple, they're not using a bunch of time to set it up. They just press a button. Citizen science this is a side note, kind of has a long history in Canada with Aurora. In 1957, during the International Geophysical Year, there was actually a campaign where you could mail in your Aurora sightings, and there were these special little reference cards they'd send out that showed the quadrants of the sky, the azimuth, what you saw and different iconography, yeah, of the different shapes you might see that are identified there. And that was actually still in the RASC handbook, I think, recently, that original drawing on the far left of the different kinds of aurora you might see. These were sent back encoded in punch cards and put out as synoptic surveys by the International Geophysical Year. I actually have on one of my websites, I found from a member at Ottawa Centre, he was participating in this. I don't know in what capacity, but he was maybe in Scouts or something similar to that, a youth group, and they were given pads of those papers to fill out. And so he was gracious enough to donate one. I scanned it, recreated it, so anybody can download it. So citizen science for aurora in Canada and North America goes back quite a ways. When the cameras were kind of deployed to various operators, they quickly came back with some very intriguing information from Manitoba, from Alaska, and from Alberta. And here's just some animated GIFs of some of the different kinds of formations they've captured. And you can see the variety of different kinds of aurora you might see. It's never the same twice. And maybe that's the allure of it. And often it's full sky. During this time period, they collected over 75,000 images. They were automatically uploaded to Google Cloud, which gets a bit expensive after a while. It's kind of like the Confederation Bridge. You can upload cheaply to Google Cloud. It's when you try and download from it that they start charging you. So yeah, they gathered a lot of imagery and they enjoyed it, and their timing was great, and there's a lot of know-how that they transferred back to me for the project. And that's a little map of where they distributed their photography with, I think, a 500 kilometer radius. One thing you'll notice around the data visualization is something called a keogram. And that's a convention in, I guess, quite a bit of all-sky imagery, where you have an entire time lapse of all night, and you want to take a look at it in a glance. So kind of like spines of a book at the bookstore, you're creating spines by taking the center vertical slice of pixels of each time lapse and stacking them left to right on a time base overnight. So you get a whole view of what happened overnight just by glancing at a keogram. And that's why there's sort of a keogram wrapped around the data visualization of the time lapse, almost like a clock or a seismograph or grooves in a record. It's a way of quickly glancing and seeing, oh, at 12 o'clock, something purple and insane happened down south. So this convention was established, I think, when the first all-sky cameras came about. What can you do with, or some suggestions that people have what you can do with a portable all-sky camera? Things like coordinating with other sensors, like cell phones or magnetometers that are collecting GPS information. Positioning it for overflights with other instruments or satellites that are also collecting aurora data. So these conjunctions, I guess, are quite valuable for researchers. And they say, oh, we've got a satellite that measures some type of, say, ionic component or flux in the solar wind. We can also correlate that with a visual sighting. If you have multiple units, you could maybe do all-sky coverage networks or even maybe triangulation if the lenses are calibrated. So, and event monitoring too. I think there was some sounding rocket launches in Alaska that one of the citizen scientists brought their camera because they were a student for it up to Beaver to witness the launches, and they'd see the aurora that these sounding rockets were being launched into. So as I spoke to people, there are more and more applications that were potentially for a portable all-sky camera. Here's one example of why it makes sense to have one of these. You can see the keogram around here, and you can see a purple line here, or a mauve line, I guess, which is called Steve, I believe, in aurora literature. It's a different kind of illumination or emission that's associated with aurora but isn't technically aurora, and so it's an active area of study since it was first sort of understood and named in I think 2015 to 2019, I'm not sure. But there's an example up in Alaska, or in Yellowknife, where you have your camera set up, you're capturing what you think you'd like to capture, but you missed out on all this, and these are synchronized now because you can have a time base. So the citizen scientists could maybe have many cameras out at different frame rates, but they all get a context with having an all-sky camera there that's linked to GPS. A lot of times citizen scientists will capture something amazing in the Aurora, but they'll not have the clock in the camera synchronized. They say, I don't really know when it happened, and I don't know what direction I was really looking. This can help contextualize their other captures. Since, I guess, October and into January, I've been redesigning based on what I've learned from deploying these initial prototypes. So it's now 3D printed, and it's stacked like a bento box. And that's to keep everything nice and warm. It's sort of like a chimney. You've got electronics at the bottom generating 6 watts of heat. So why not use that? It's got circulation up over a battery, which is more temperature resilient in the cold. It's lithium iron phosphate instead of lithium ion. So it heats the battery, keeps it warm, and then goes up around the camera and exits. I don't know if there's a laser here or something. Yeah. And it should exit around the lens to provide some frost prevention or heating, just a little bit. So we don't want to put an acrylic dome over the lens because that really compromises image quality for Aurora and wide angle. So we have to keep it defrosted to some degree. So this is the new design. We tried to keep the cost down by using consumer cameras like the APS-Cs from Sony and Canon. I think this is probably a video, so I don't know if it'll play unless. Yeah. And maybe it's the next slide. This looks like it should be a video, but if it doesn't play, that's okay. It's a very low resolution thumbnail of a video, so we'll come back to that. As part of the automated pipeline for these, so that it's really easy for people to do, I wrote some scripts that create the time lapses and bump them up to YouTube, because hosting gigabytes of video can be very costly, whereas YouTube is free. It also allows you to share it with people. They can share links to specific moments. They can add comments, and they can add chapter markers and say, I saw something weird at 6 seconds into the time lapse. So despite the ads in YouTube, it's still a good way of disseminating the information. And people can say, I'd like to see these frames from this night. And they can receive the original frames that way. So it's a good way of sharing that doesn't cost a lot and reaches a lot of people. Some other outreach and collaboration that happened was, speaking of, Lisa caught the SpaceX launch. This was the second stage when it's spiraling and venting, I'm not sure it's thruster gas or maybe residual propellant. And that's what it looks like overhead. It was coming over a North Pole to South Pole, I guess a polar orbit. And we actually saw this weird galaxy thing just go by the field of view, which seemed immensely odd because it did look like you were looking straight into a galaxy. And it turns out that's one of those stages, the second stage, I believe. But that also shows why it's good to have co-location, or you'd have you'd be able to synchronize with where satellites are that are taking measurements, like even GPS satellites. We also brought it up to University of Alaska Fairbanks to test it in their domes. And it was used in some outreach and education recently where we did a special video of this that could be projected by planetarium projectors. I think they need a 4,000 by 4,000 pixel MP4 that they can project backwards onto a dome. And that's all really, the geometry exactly reverses from an all-sky camera lens, so that now you can have a planetarium or dome show. And it would be fun to try it actually in Halifax, if possible, at the Discovery Center. Yeah, that's the link for the YouTube channel in a QR code if you're interested. YouTube also allows you to do something else. This is a video, but it's not going to play. YouTube also allows that kind of immersive VR thing. So you can say, you can upload the video and then look around. If you're watching on YouTube on a phone, the accelerometers in the phone are linked with your field of view. So it's like looking through a set of binoculars up at the Northern Lights if you want to. So that's one thing that we tested with this too. Dr. Elko Dornbos is creating something called the Space Weather Timeline Viewer app, where you can look at magnetometers, you can look at information from interplanetary missions that are gathering information about the solar wind, about magnetic anomalies, about disturbances. And he decided to synchronize the YouTube channel Aurora videos with his interface. So now you can, as a citizen scientist or a scientist, quickly say, I want to see the magnetometers that were close to this image. I want to see what the interplanetary magnetic field was doing around that time. And in this case, it's highlighted here that there's a little magnetic disturbance at this magnetometer. And as the playhead comes right about there, it gets really busy optically. And that's sort of a well-known correlation. When there's a disturbance in the magnetic field locally, you'll see that overhead aurora. There's a lot of open work to do with this, I guess. Like everybody has ideas about what they could do if they had an all-sky camera. Building and deploying more units, I guess, to people that are interested in doing that in a sustainable way. And also calibration and characterization of it. It is a consumer piece of equipment, and there's a ton to learn when you're using consumer equipment. A lot of things that are sort of hidden away in the cameras you only discover retroactively, or characterizing the fisheye lens to see whether it's really mapping altitude to pixel positions. So that's something that I think is kind of ongoing, and I have to learn a lot about. Is this the right direction? Yeah. And yeah, here's another version of the case. It's done in transparent PETG plastic, which is pretty resilient. It's what you make a pop bottle out of. And you can actually see all the LEDs through the plastic at night. So it looks like it's holding Aurora inside it because it's RGB as well. So it's kind of neat. And it keeps people from running into it at night, because often it's set up and there's lots of Aurora chasers around and they're bumping into each other's equipment. So it's kind of a safety measure too. And that's the top internals, where you see a mirrorless APS-C camera, an all-sky lens from Mikey. I think they're only about $150 now, and they're made of metal. They're very good quality f2 lens. And a lithium iron phosphate battery slips in the middle, and you can pull it out and replace it just like a cartridge if you want. And we've also done sort of a USB-C interface. You can put in whatever other battery you want or power it externally. So the idea is to make it as modular as possible. And here's one deployed right on the shore of Lake Winnipeg in the snow. It has little feet instead of being on a tripod or anything. And there's the glow from all the electronics. And it's just, I don't know, that's kind of interesting that it looks like it's aligned and with your, and here's what it captured that night. So just in my garage lab, I guess, made a few others for other people that are interested in them, and kind of looks like a little assembly line, I guess, but I still have a ton to learn. Here's an example of something that's been bugging me lately, is using a consumer camera. It's all about noise floor, and I'd love anybody's information or knowledge on noise floor, shot noise, telegraph noise, amp glow, anything you know about that, and specific to Sony Exmor sensors. I'm noticing that frame to frame, there's a change in the black point and RGB channels. This is two separate frames. Notice one is redder than the other. And so it's like the black point drifts from frame to frame. And I'd love to know why. I've tried to narrow it down, but there's not a lot of literature about it. So something to find out. So I'm happy to engage with anybody that might have an idea on that. Otherwise, I'm just going to try and cancel it out. Yes?
What's the time difference between two frames?
Oh, thank you for asking. That would be around 2.7 seconds.
Could you shoot darks in between?
I did test that. There is a long exposure noise reduction built into the Sony cameras that takes an automatic dark frame and subtracts it automatically, as I understand it. It didn't work. I still had that color cast. It did, yeah.
Frame to frame.
Frame to frame. And that's why I'm a bit baffled. And it's frame wide too. It's not just amp glow, although there is a bit of an amp glow gradient. It's almost like the black points of the RGB and pixels each vary by 0.1% every frame. And it's kind of baffling. So I'm trying to write software that will compensate for that, because you have a black sample area here in each image that isn't exposed that you can use to determine what the black point is and maybe subtract it.
Could you just repeat the question briefly as to what you just answered?
Oh, yeah, sure. So the question is, can't you just get rid of this by using a dark frame in between each consecutive frame? And I tried that with the built-in system that's in the Sony cameras. It does exactly that according to its documentation, and no luck. It made it maybe a little less noisy, but it didn't get rid of this color cast change between frames. So yeah, definitely something that's been on my mind lately, because that kind of flicker does show up in time lapses, but only sometimes. A puzzle to think over. If anybody knows somebody, please feel free to get in touch. Yeah, so I guess that's the presentation there, and I'm open to questions. Now, I don't know what time we have left. Oh, okay, yeah.
I'm going to be I am naive about cameras and all that sort of stuff, but I'm wondering, with respect to, you were talking about your battery getting cold inside that AED case. What would happen if you put a hand warmer?
Yes, that is exactly what I was doing as a mitigation. The foot warmers, actually, because they're bigger, and they are sticky to stick to your socks or your boots, so I just stick them on the battery. And I guess that's something that a lot of the Aurora photographers do. They adhere them to the magnesium or aluminum cases of their cameras. There's even somebody we know that makes a little puffy jacket for their camera that still has 2 armholes in it. So you can modify the controls, but it's got a little parka on it. So I guess it's a known thing, trying to keep your camera and especially the battery warm. Originally, I used Canon cameras for this because Canon was familiar with their workflow. But they all use mechanical shutters, or at least at this scale, they use a mechanical shutter. Those are good for, or rated for, 100,000 actuations. And if you're shooting 8,000 frames a night, your camera is like out of warranty in a week or 2. And so I had to move to something that had a purely electronic shutter. And that was that was why there was that big move to Sony, because at this scale and this size, they do have the fully electronic shutter. We also considered full frame, because you think, full frame sensors are twice the surface area of an APS-C sensor, you'll get half the noise. But the prices also double for everything, more than double when you go to full frame. And this is supposed to be citizen science, inexpensive. In fact, these cameras here oh, sorry, that's something else. These cameras here, this isn't even the latest model, but you can find them on eBay for $600, and then the lens is another 150. That's fine to digest for a citizen scientist, especially since they can pull it out and use it for whatever they want after. It's not permanently installed in the system. So people said, why don't you go to full frame? Well, full frame, a lens like that is typically f2.8. So now you've canceled out the double the size of sensor that you had. You thought it's twice as big, it'll gather twice as much light, but now your lens is half as bright and you've paid twice as much for the unit. So it didn't make sense. There's kind of a sweet spot, and I guess that also people suggested using a ZWO planetary camera, and the prices for those, for the same Sony sensor, because they do use the IMX Sony sensors, and the APS-C sensor size for the ZWO planetary cameras is well over $1,700 for just the camera. So for that, you could have bought 2.5 of these, and it's the same sensor. So is it worth figuring out these quirks like that black point in order to make this more accessible and have more of them? That's sort of the trade-off, I guess, I'm facing using that technology. Yes?
So forget backyard observatories. When are you building your backyard planetarium?
Oh, geez, yeah, wouldn't that be nice? I'm definitely open to bringing one of these to the next event because it does have a phone interface and its own Wi-Fi. So anybody, you could set up a screen next to it and see the full sky or the galaxy if it's dark enough, and just sort of see a contextual view of the night sky with 15-second exposures. And I guess that's been used as a live outreach. When there are tour groups taking the Aurora out, they all have their own cameras, but then they have one of these set up that anybody can log into with their phones and just look at the full sky context. And the way I've used that is I sit in my car to warm up when it's minus 30 or more in Yellowknife, because you can't stay out for more than 20 minutes. But you can at least leave this out and see when the aurora are starting to build in the south or the north. And you say, oh, it's happening. And you can hop out of the car and start setting up your other cameras. So it kind of acts as an observatory too, in its own little way. Yes?
Two-part question. First, what is your exposure time and what factors determine what exposure times you want to go with?
Oh yeah, that's a great question. So what is the exposure time and say ISO sensitivity, and what factors go into determining that? For active aurora, and you can see it down here, typically aurora chasers are really looking to capture the motion. And so you want your exposure as short as possible without compromising the noise level. So we found around 2 seconds at ISO 3200 is good for active aurora. For aurora that are more on the horizon, for example, the ones we deployed recently in New Zealand, they're looking south over, I guess, Antarctica. And those are more towards the horizon, and they shoot maybe 15 seconds at ISO 3200 or 1600. So that's sort of the range we're working in, anywhere from 2 seconds to 15 seconds, and right around ISO 3200 for this camera anyways. And that's with an f2 lens.
I said 2, this might be 3. Do you find, going back to the problem you're having with color between frames, does the 15-second exposures that they're doing in the Antarctic have the same problem or less of the problem than you do with the shorter exposures here?
Oh,
I'm wondering about saturation of the...
Yeah, so the question is, when you do a longer exposure, I guess they're in New Zealand, I guess, not Antarctica, but they're sort of pointing south. And does a longer exposure reduce this? It certainly increases the signal to noise ratio, because shot noise it varies in proportion to, I guess, the square root of your signal. So you get a better signal to noise as you'd expect with a longer exposure. But it doesn't seem to improve or change this black level color cast at all. It stays the same pretty much from what I can tell. Yes?
My original second question was, based on 2 seconds to 15 seconds at 3200 at f2.8, doing? The lens was f2?
It was, yes, f2
Have
lens.
you considered cross use of this not only for Aurora, but for all sky, bolide, fireball detection?
Oh, yeah, thank you. So the question is, can this see other things other than Aurora? And yes, actually, speaking of the backyard observatory that you mentioned, I did set it up in the backyard during a meteor shower, and because I wrote the software, I can write a frame stacker for it, so you get the full star trails, and it captures any fireballs that might happen. It worked. So I think for that one, I was doing 15-second exposures for it, but there's no difference between making a time-lapse sequence and just stacking them if you're willing to get into the Python software and write it, or use other stacking software, I guess. So yes, it did work as a fireball catcher, but I didn't write any software because I'm not sure how that actually identifies fireballs and differentiates them from all the Starlink and aircraft and things like that. So does that answer?
It could be used for meteor showers.
Yeah, I'd be certainly willing to try it. If anybody has dark skies and wants to try out one for that, we can figure out something. I think that'd be fun, yeah.
The frames that you're shooting, are they being shot raw or as JPEGs?
Oh, thank you. That's a great question. Is it JPEG or RAW? And the answer is both. However, we have a constraint due to citizen science. Where are these citizen scientists who see the aurora all the time located? In places with very poor internet. And at best, only recently, they've gotten Starlink, which gives you 2 megabits per second upload maybe. And uploading a night of raw images would take more than a night. It would be slower than real time at, say, 24 megabytes per image and 5,000 images. So I've sort of made the choice that it should be JPEGs at 2 megabytes each. And of course, that bakes in a lot of post-processing that you have to account for.
The reason I was asking is you can get color shift in the JPEG conversion. That might be ways to have it.
Yeah, I'd love to learn more about it for sure. This is in RAW. I wrote something that actually makes a more compact RAW by using Bayer-aware binning and things like that, and trims the image. And unfortunately, the color shift is visible even in the raw data, which I thought for sure it would just be a JPEG processing thing that was going on. So I'm happy to chat more about it maybe offline and figure out those things. But as with anything in instrumentation, it can be a mystery. The deeper you dig, the more you find, I guess. So any other questions? All right. Feel free to visit the website and check out the YouTube channel. There's quite a few videos from people all over the world who've tried these out and captured some neat time lapse. And yeah, I'm always open to people getting in touch with ideas and applications, like you mentioned, the Fireball stuff. Thank you. Thank you.
So I guess I'm up next. Can you hear me? Okay, good. I can't hear you because I had to take my hearing aids out to not have myself talk to myself. So we had the idea that we would compare our new toys out at SCO. So the best laid plans of mice and men. What you need is the equipment, the location, and the weather. So things didn't go quite as planned, but we did get a few nights of imaging with the toys we have, the Seestar and the Dwarf. And we have processed these in PixInsight and other apps to get a look at how these compare. What are the trade-offs? So for the equipment that we have here, the ZWO Seestar S50 sort of started it off. They came out with a 250 millimeter focal length smart telescope, and it is quite impressive. It does a lot, but it was a little expensive for most people. And shortly after then, they came out with to me, an unexpected smaller version, the S30. So 30 millimeter aperture compared to 50 millimeter, and down to a focal length of 150 millimeters. So it is this here. For those of you on Zoom can't see what I'm pointing out. Maybe you can, yeah. And to our left, we have an S50 and an S30 Pro. Finally, they came out relatively recently with the S30 Pro, which improves the computer, slightly better optical. This is now, I believe, a 4-element lens and more features to it. So round it off, the Dwarf 2, which is now being replaced by the Dwarf 3. I believe David, who was David McMullen online, has a Dwarf 3, and David Hoskin has a Dwarf 2, which we'll see some aging from. It's 100 millimeters. It was, I'm not sure, was it out before the S50, David?
Yes, just a little bit.
Yeah, so these came out about the same time, the S50 and the Dwarf 2. The Seestar products have maybe a more popular because ZWO is a larger company in the sense of the other things they make. But Dwarf 2 has had quite a following for their products. So a little synopsis of so I forgot to point myself at myself, but maybe it's not important. The sensors have changed as the devices came online. Started out with 1080 by 1920 and have migrated up to as far as 3840 by 2160. The later versions have also a wide-angle camera, the S30, S30 Pro, and the Dwarf 2. And those are used to assist in locating objects and for landscape-type applications, not necessarily as much for astronomical work. So to see the effects of these different focal lengths, this is the 5-degree circle here, Andromeda in the center, and Seestar S30 Pro is the widest field of view because it has more pixels for about the same focal length. The Dwarf 2 has it right in my mind that their sensor is horizontal, and it's not quite as large as the Seestar S30 Pro. We move down to the Seestar S30, and finally in the very center, the Seestar S50. So a much smaller field of view, but better optical resolution because of the aperture and focal length part of it. Trade-off with the S50 is that if you did want to capture something like the Andromeda Galaxy, you would have to mosaic, and that implies taking multiple pictures around that central point and then stacking them together. So that increases the time to get the same amount of information for that coverage area, or the area you're looking at. So there are also two modes of using these. The simple Alt-Az mode, which is just, as you might know if you have a telescope, Alt-Az, left, right, up, down, and that works reasonably well. It's quite simple to set up. Two of these here in the room are in Alt-Az mode and one in equatorial mode. Picture on the right is showing in equatorial mode, where just like all EQ telescopes, it's pointing towards the celestial pole, and that improves the tracking and lets us increase the exposure. So what do you get? So here's the S30 Pro, the widest field of view, the Christmas tree cluster, and a 10-second exposure. This is a single frame from the camera. To me, there actually is some red glow in there on the screen, so here the projector is not really reproducing that. This is very similar to what you would get through an eyepiece. So you start with this, and it might look like what you would normally see looking through an eyepiece. The value here is, rather than, well, it might look like what you would see if you would have your eyes expose themselves to an image for 10 seconds. But if you go ahead and get 213 10-second images stacked together, which it will do automatically, then you start to see some color and the extra detail that's in there. So this is an image from the Seestar itself. The software in your phone is getting data from the Seestar, and in this case, presenting you with a stacked image that it has enhanced. If we take that same 213 images and bring it back into PixInsight, this is a simple screen stretch. Doesn't look quite as impressive as the previous one, but in fact, you can go ahead and apply various adaptive stretching to bring out more detail. So this is the multi-scale adaptive stretch in PixInsight. I like to use it because it's simple and I almost understand how to use it.
Jerry.
Maybe. Oh,
Question, Jerry?
yes.
Jerry, question for you. I know you can download each of the images out of the smart telescope. Can you download the combined image but unprocessed in any way?
So the question was, you can download these images, the individual subframes, to your computer to process, as done here, but can you download the stacked but unprocessed image that the app itself created for you with the system. So the answer is sort of. It will stretch it and give you a reasonable image, but you can go further within the app to say, I want to do an automatic background removal. You ask it to do that, and it will improve the image. So you can't get
the unstretched version.
unstretched version. Not that I'm aware of, at least.
You can export it
Yeah.
on the fly.
Yes, you can export it. So here's the multi-scale adaptive stretch, and then I also tried this more impressive, perhaps, generalized hyperbolic stretch. And for the same data, you are getting more information out of it, although I'm not very good at using the GHS here, so that Blair, as an example, and Bob are much better at using GHS, and they get better results, as we'll see in this. But you can actually get more information out of what it produced to begin with, at the expense of time and money. So that was the S30 Pro. If we zoom in effectively by switching to an S30 on the same target, in this case we took 106 60-second images. This is in equatorial mode. Basic screen stretch, you see a little bit more detail there. And if you go to a mass stretch, you can end up with a completely different image. My processing skills are something like my carpentry skills, and the lightning never strikes twice in the same spot. So I never can end up with the same result twice as I do any processing. So it's all over the map. So there's an MAS stretch, and there's a GHS stretch of that same product.
Looks good.
Well, it looks good. Yeah. If you haven't seen some of Blair's, it looks good.
Do not compare yourself to Blair.
Thank you. So, moving on again then, if we switch to the 50 millimeter S50, hiding itself underneath the display there, this is 301 10-second exposures. I don't know if anybody wants to talk about why we're using 10-second exposures here, but the reason is that the S50 generally it's not actually capturing that many images that successfully. Lately, it appears that it will reject more and more images, so that it looks at each image it captures every 10 seconds and says, that's not good enough. I'm not going to include that. So here we have 50 minutes worth of good 10-second exposures to produce a result, but in reality, it might take a lot longer to get 50 minutes than the other two scopes, or 3 scopes. But if we take those and process them with GHS stretch, we get a good image. I think, in my opinion, that there's a lot of detail there you can see for such a small telescope. Again, if you give it to someone who knows what they're doing, this is Bob Russell's, they can produce pretty good results. So relatively short exposures work. The S50 again, this is 10 minutes, 63 at 10 seconds, using the MAS stretch. But if you finally realize that you forgot to put in the other 400 images and process it again, you end up with more detail than that. So as with normal astrophotography, the more data you have, the better it looks. This is the Flaming Star Nebula. So a different stretch, again, is 50 Peters GHS stretch. Here's an example with an alt-as image. Field rotation comes into effect with these, in that as it takes individual pictures tracking the sky, same part of the sky, the actual sky in its field of view starts to rotate because of the rotation of the Earth. So the corners of the image get less exposure than the center. The center occurs in every frame. The corners, as it rotates around, get less light. So you end up having to take more exposures or a mosaic to cover a particular subject. So that's an MAS stretch. Here's the Markarian chain with the Dwarf 2. So it's done a good job, I think, with Stellar Studio, which is their processing software. It's a little bit different than the Seestars in that the processing is online.
Yeah.
So
the
you
Dwarf 2 doesn't have the CPU power to do it.
right. So Dwarf 2 can't do it locally with the CPU it has. So it intelligently sends it off to their cloud. They do the analysis and give it back to you. And David has, oh, it's got my name. This isn't mine. It has, David has tweaked it up a bit with Photoshop. So, a different telescope, the S30 Pro, very similar, same target. What were we at earlier? In the previous image, we were at 76 minutes. This is 62 minutes. So very similar result. MAS stretch because I'm lazy. But what do you see? So this is a count through PixInsight of or labeling of the galaxies that are there. It actually had imaged or labeled a fair number of extra galaxies in there that I went in and removed by hand the labels because I actually, when looking at it at 1-to-1, I could not see anything. So it knew there was something there, but it wasn't actually looking at the image to say whether did you see that or not. Blair.
Jerry, when you use that annotation script in PixInsight, it doesn't label what's there, it labels what's in the database. So it will put a label up whether the galaxy is there or not.
Exactly. Exactly. Yeah. So the point was that it puts a label up whether you can see it, whether it saw it or not. Correct? Yeah. So anyway, believe it or not, were you to see that in real life, each of those has a smudge of some sort recognizable as a galaxy. So it's pretty good. And this is essentially an hour's worth of exposure. So Blair, I know, is working on, I think, what will be a 5-hour exposure of the central portion of this. So it'll be amazing to see what is actually there. So moving on, Dwarf 2, M42, Orion Nebula, did a very good job. He's controlled the central area, which is quite often overexposed. And this is 16 minutes. We go to the S30 Pro. Here's a single 60-second image that I took that maybe I shouldn't be using 60-second images because the center is pretty well overexposed without stretching it. So if you do take that, all of those, here's 38 minutes worth, and stacked by the app itself, the Seestar. It has the detail there, but it doesn't actually effectively control the overexposure. So you can tame that blowout in the center by using PixInsight as an example, the MAS stretch, and as was shown earlier today, you can really mangle it if you want and try and get down to seeing the triangulum in the center. So controlling the gas clouds around Orion and the central nebula is a bit of an art. I think Bob here has done a very good job of, you can see the stars in the triangulum in the center, and there's still detail on the outside.
Jerry,
Yes.
how are these mounted? Are they all dazzling, or are they?
These are almost entirely EQ mode. They're not all passive.
The equatorial mounts?
Yeah. Well, just as in there, it just tipped over, right?
Yeah.
They eventually just came up there. somebody, the question was, how are they mounted? Well, most of our shots, maybe not for the S50 completely, most of our shots are in equatorial mode because someone started experimenting with these scopes and determined that, oh yes, you can put it in equatorial mode and cheat a little bit and get better results. Essentially only one motor is moving. So eventually ZWO gave in and said, oh yeah, if it's becoming so popular, we'll actually come out with it. So now that it knows about equatorial mode, and if you tell it that you're in equatorial mode, it handles that.
So will my old one, if I update the software, be able to handle it on
It's S50?
Yeah.
Yeah, no problem.
Okay.
That would be an interesting question we should ask later at the end. How many smart telescopes do we have? When we were at SCO on Wednesday night, there were 7 smart telescopes in the field, a couple of other telescopes in use, and 1 person visually observing. So it was a little...
the times they are changing.
yes, it was a little eye-opening to believe.
Someone said the number of smart telescopes is the number of dumb images.
So Peter took this again with his S50, and it's 59 minutes, and that's with the MAS stretch. But if you use the GHS stretch, you can try and dampen that down a bit. And there's a trick here that I believe I used from Blair's tutelage, that you put a mask in and you just concentrate on the central area and really process that separately from the rest of the area. That lets you control both at once. Spinning ever so slowly, Dwarf 2 with Pinwheel Galaxy. Stellar Studio, Cyril, and Photoshop. It looks pretty good. It's not very big, but then again, with the S30 Pro, it's even smaller. Stretched. S30, not quite as small, a bit more detail. And the S50, zooming in even further, this is with our Alt-Az mode, so there is field rotation. I think you can see in the upper right, there's a line of between black and dark and lighter, and that will be part of the field rotation effects. And the S50 again processed 34 minutes in equatorial mode. So you can get a lot of detail here. The screen is not necessarily showing that as well, but 26 minutes on M13. Looks pretty good. So there are, of course, some targets you may not choose to use if you're rational. So with my S30 Pro, 51 minutes worth of the Crab Nebula. So what did I end up with? Well, if you zoom in ridiculously, you can see, yes, there is a Crab Nebula there, but maybe not as good as some pictures of the Crab Nebula. And for the record, the Hubble is on the left, if you're not sure.
I thought that was your screen, Jared.
Yeah.
Anyway, last but not least, darker horse here with the S30 Pro, the Horsehead and Flame Nebula, 79 minutes. This is from Wednesday night with a stretch. The first one there was the Seestar app itself. Now this is the in PixInsight, and now we've zoomed in a bit with the S30, almost the same time, 79 minutes, running at the same time, MAS stretch. So you can see more detail around the Horsehead itself, but not quite as much detail as you might get. So here's the S50, and you're starting to see more detail around the head itself. we're not getting with the other scope. That's that, and then Bob also has 6-minute exposure where there's detail there. So that's it for pretty pictures. Why are these interesting to us? I think primary strength is public outreach. These tend to bridge the gap between an eyepiece and the online imagery that you might see now on from Hubble, etc. So they have their strengths and weaknesses. The Dwarf 2 is pretty good, pretty simple to use. To begin with, the software was not great. Is that right? And then the S50 came along at the same time. It has better optical resolution, so as you might expect, it's working to give a better result if you're willing to wait for it. Currently, it's struggling with image rejection, and people are experimenting with putting weights on the side of the scope to get rid of the
Backlash.
slop in the gears. And that apparently is helping some people. S30 came on a year later and was cheaper. It had more bells and whistles, wide-angle camera you could use. And finally, the S30 Pro, relatively recently, with a 4-element quadruplet lens and about the same resolution as the S30, but more pixels, so giving you a wider field of view. It has extra modes, Milky Way mode, giving star trails, improved sort of automatic mosaic stitching, and more memory, but then again, the images are larger.
Jerry,
Yes.
you mentioned the Milky Way mode. What is the Milky Way mode? Is it literally just a wider perspective on the shot?
The question is, what is the Milky Way mode? I actually haven't used it much, but it is the other wide-angle camera on the scope, so that it will take a picture with this higher resolution 3840 camera. It also has the same sensor scale, and give you one up to 8-degree field of view, I think, in a single image. And there's a panoramic option for that. But I haven't had the chance to play with that yet. So if you are interested in these at all, currently we're scheduled in theory to give you a bit more of this data and results Nova East. We encourage you to go to that. So we will be looking at the Milky Way mode and some of the other modes by then, and maybe have some better pictures. This is a S30 picture there of the rosette. Question, Bob?
Just a comment, maybe the S70 will be out by then.
Yes. So I presume, given you have a mic there, that everybody heard that.
Yeah, I think it picked it up.
Yes, so we are hoping that at Heath, which is coming up, there might be yet another Seestar in the lineup.
Dwarf is releasing a new product.
Ah, excellent.
Big mystery, don't know what it is.
Right. The wars continue.
To me, the stars images seem big. Is that because of the small lenses?
Sorry, I couldn't hear that. So,
What?
without my hearing aids.
The star images seem big. Is that because you're using small aperture lenses?
The stars themselves seem bloated, sir?
Yeah.
Yes. I would say that's something I don't want to give an answer for.
Is it simply the optics because there's the resolution of the lenses, or is it in the
Yeah, we can't hear Dave.
Blair might have a better answer for that.
It's probably due to the aperture. I mean, smaller aperture make bigger stars.
Okay, so Blair said it's probably the aperture. Yes.
Peter and I are working with the folks at Keji to see if they are interested in switching over to using something like the Seestar for their public outings rather than the telescope, which they're still having a hard time using, and only one person can look through it. So we're talking about setting up a screen and having the thing as it's developing being shown on the screen, and people can talk about, yes, we're actually seeing it and all that sort of thing. Thing is, I mean, I have one and I can sort of use it, but I wonder what people's idea is, whether they think that might be a good idea. And secondly, is there someone here who wants to volunteer to help us get them converted over if we decide to continue that road, down that road?
Well,
Are you volunteering, Bob?
I'll give you a hand.
All right, thank you very much. I think there's going to be a break, but slightly before that, there's another activity.
One of the thank you, Jerry. One of the privileges of holding the role of president is that you have the opportunity to present awards that have been received by deserving members. And today I have the very great privilege to present Judy Black with the RASC Service Award. The Service Award is a come down here, Judy. The Service Award is a major award of the Society, and it's given to a member in recognition of outstanding service rendered over an extended period of time, where such service has had a major impact on the work of the Society. So, Judy, I would like now, I'm just going to read for the Assembly here and for folks in Zoom the nomination, because I think it's important for folks to hear this. The nomination reads, it was with great pleasure that we nominate Judy Black for a Service Award in recognition of her exceptional and sustained contributions to Halifax Centre and to the Society as a whole. Judy has consistently demonstrated outstanding leadership, organization, and dedication. She has served as both a driving and unifying force within the Centre, playing a pivotal role in the planning and execution of events and ensuring that every activity is conducted with efficiency and professionalism. Judy's contributions to the Halifax Centre administrative framework have been particularly significant. She has worked tirelessly to develop and maintain comprehensive records, as well as clear documentation of processes and procedures. Because of her efforts, the Centre's policies are current, accessible, and invaluable to the Board of Directors. Her diligence has established a foundation of continuity, transparency, and accountability that benefits the RASC Halifax Centre today and will continue to do so well into the future. Judy has served the Centre in several key leadership roles, including President from 2020 to 2022, Halifax National Council Representative from 2021 to 2025, and as the Secretary of the Centre from 2024 to present day. In every capacity, Judy has exemplified collegiality and integrity. She fosters an atmosphere of cooperation and goodwill, and she consistently leads by example. If something needs doing, Judy is always among the first to volunteer, whether leading an initiative or supporting others. And when she says, "I'll look after that," everyone knows the task will be completed promptly and to a high standard. As National Council Representative, Judy has strengthened the connection between Halifax Centre and the broader society. Through her thoughtful engagement and clear communication, she has helped not only Halifax Centre, but all centres participate more effectively in consultation with the National Council and ultimately the National Board of Directors. Judy's approach to leadership is forward-looking and constructive. She does not dwell on past challenges, but instead focuses on opportunities for growth and collaboration. Her inclusive leadership style and ability to build strong teams have been major contributors to the ongoing success of RASC Halifax Centre. For her exceptional service, commitment to excellence, and lasting impact on the operations and spirit of RASC Halifax, we are proud to nominate Judy Black for the RASC Service Award. Her dedication and professionalism exemplify the highest standards of volunteer service within the Society. So Judy, congratulations. It is my distinct pleasure to present to you today the RASC Service Award.
Thank you. It could be. Yeah, there it is there. Actually, what I'll do is come so.
You gonna make a duck face?
We got a better background.
One of your photos.
Yeah, there you go.
One of those smart
Good call,
phones.
Dave.
But the last one that you had there with the rosette.
Not the Crab Nebula.
Well, why don't?
Don't give him an opportunity for comment.
What about the Witch's Broom? That be a good one?
The Witch's Broom? There's the door.
Oh, that'll do.
That'll do? Good. I don't know who to look at, so look in the middle.
I'm just gonna take a whole bunch. Okay, good.
Thank you.
Thank you. Thank you.
And thank you again. Thank you. Thank you. So I guess we're gonna break now. As you may notice, there are some boxes here on the tables.
Okay, so we're back again, and our third member's presentation's Judy Black. She's going to make us laugh.
I hope so. Thanks, Dave. Whoops. Can you start the presentation, dear? So, funny you should ask. I thought about this eons ago because I collect cartoons. And initially my collection for cartoons was because of my role with the Heart and Stroke Foundation. I taught CPR. And I taught CPR for not only the general public, but also to train new instructors. And of course, part of training new instructors is you want them to use humor, but you have to teach them how to use it effectively. And cartoons always brought out key points really, really well. So when I got involved with astronomy, I realized, you know, there are a lot of astronomy cartoons out there from cartoonists like Zitz, Betty, The Other Coast, Garfield, all sorts of other comedians, if you will. So I started to collect them because I thought that, well, this is really cool. And I guess maybe about last year sometime, I thought, you know, it's always about science with respect to astronomy. What about the humor in it? What about bringing the laugh to the classroom and that sort of thing? And no, I do not know these people that are laughing so wonderfully, but they had such beautiful expressions on their face, I couldn't ignore them. So for those of you that don't know me, I mentioned a few moments ago, my life changed. I went from teaching Heart and Stroke Foundation CPR and getting sore knees when I went, Annie, are you okay? To joining astronomy in 2013 or so, and looking up and getting a crook in the neck. But nonetheless, still had joyous moments. Oop. So, why use humor? Well, first of all, it captures attention. A laugh resets the room, and people that weren't paying attention look up. Oh, why is everybody laughing? What did I miss? Right? Wrong one again. Sorry. Try this one.
Part of the humor, is it?
Part of the humor. It builds connection, right? When you make people laugh, they feel closer to you. I'm not just the presenter here at the front of the room. We're here as a group of people interacting together. It reduces the tension. And no offense to the finance and tech people in the room, but sometimes when you're talking about these very serious topics, you do have to introduce some humor to the presentation so that it lightens it a bit. But most importantly, it improves retention. Studies have shown us numerous times that if humor brings things from short-term to long-term memory, and if you think about your own lives, think about a long trip that you took. Do you remember the breakfast you had on a specific day, or do you remember the funny event that happened on that day? So it brings the funny moments, bring back the memories. I'm going backwards again, aren't I? No? There we go. There. So.
That's your pause. Yes.
It is. We pause for effect. A beat before the punchline creates anticipation, and a beat after gives the space for that laughter to occur. Use body language, facial expressions, the anger, the happiness, whatever. The raised eyebrows, the shrug. Any body language that you provide to your audience also gives them a cue as to how they should be responding to whatever it is you're presenting. And don't over-explain. We all know that if you have to explain a joke, it's lost. And don't try too hard, because then it becomes as painful for you trying to deliver it as the person receiving it. And I guess I should press that button. And don't be afraid to laugh at yourself. Okay? Others in the audience may be feeling as nervous as you, and it's a good way to help relax yourself as well as the others in the room. So, one of the things I'd like us all to remember is that the RASC does have an inclusivity and diversity policy, in which we have to recognize the fact that we are such a diverse group, and you may be presenting to a very diverse group, either here at the RASC meeting or out there at your education and public outreach events. Always consider your audience. What may be funny for one group of people or one type of workplace may not be appropriate for another, so just keep that in mind and avoid the types of things that I've listed there that could be sensitive topics when you're presenting. So, poetry. Now, we all know that poetry, by and large, is not meant for humor, but it can be. And back in 2022, when I was president, excuse me, we were just coming out of COVID, and we were about to go back to SCO. And I was making that announcement through the president's message in that edition of Nova Notes, and I came across this little poem, author unknown. I look at the stars, and I see you. I look at the moon, and I see you. I look at the trees, and I see you. Please step aside, you're blocking my view. So, about kids in astronomy, is there a minimum age that you should show kids? I don't think there is. If you look at the picture on the left, if you can see it, there are two children there. One is our 2.5-year-old granddaughter, the other is our 5-year-old grandson. The 2.5-year-old actually got to see the moon through the eyepiece, and yes, we knew she saw it because that part of her face was very well lit from the eyepiece. But William, our 5-year-old, is looking at Saturn's hoops. He did not refer to them as rings. To him, they were hoops. So he got to see that. And that was back in 2018. 4 years later, our granddaughter is now 6. Excuse me. I just acquired a brand new telescope. I'm looking through the eyepiece, but I love this picture because of her facial expression when she's looking through the finder. Still seeing the moon, but there's that wonderful expression. Come to September this past year, William, who's now 12, he had been attending with his parents the Dark Sky Weekend for 3 subsequent years. And thanks to Tony Schelling, he had been attending the binocular table those 3 years. And Tony always showed Scorpius and Antares and the teapot and whatnot. And that particular night we had him out at Swiss Air. William's greatest achievement, as far as he was concerned, was actually seeing all of Scorpius above the horizon. So to him, that was absolutely phenomenal, that you could see all of the tail. You could see all of it. And he commented on that all the way home. So it's building that two relationships for children when you show them the night sky. One is certainly with the night sky itself, but also you're also building that and contributing to the relationship you have with that child. So here we have this wonderful cartoon, Baby Blues. There's the Big Dipper, kids. The big what? All I see is sky. Right. Right there, the stars that look like a water dipper. What's a water dipper? That's just a bunch of dots. It's also part of Ursa Major. There's an army guy up there? Seriously? Is he in a spaceship? No, those stars are the shape of a bear. What are you talking about? Bears don't join the army, Dad. If they do, maybe this wouldn't be so boring. So,
It's on my fridge.
So you look at this poor father trying to explain to his children, and I'm sure those of you that have tried to do this sort of stuff with your own kids realize that sometimes it's a challenge. So how did that poor father feel? Well, how was the stargazing? Galileo would weep, right? So this is night 1. So he's showing his children the night sky in night 1. So now he's into night 2. So now what happens? Can you find the North Star, Hammy? Nope. How about you, Joey? They all look pretty much the same to me. Guys, I just showed you this last night. You didn't say there'd be a test. So that aspect of EPO, as astronomers and educators about our night sky, we like to provide that oh wow moment, right? you will find sometimes when you go back to groups numerous times, there will be some people that have attended all your sessions, and so when you're pointing out the same things all the time, they're not really engaged. So sometimes we have to show them a different thing, a different aspect. And so this Rose's Rose cartoon does it beautifully. So that he's roaming around, this is boring. And then this hand comes out and picks him and points him in a different direction and said, problem? Is there a more scenic route? Look over there. Whoa. I'm always available for in-flight destination upgrades. So as EPO people, this is what we have to be at times, is that dark sky tour guide. And we have to show them something new, something different, and maybe in a different direction of the night sky than what they're looking right now. So, what about solar science? Well, we know that for millennia, we've been viewing the sun as a human race. And we've learned all sorts of neat and wonderful things about the sun, which I won't go into. There are some listed here, but I'm sure there's a heck of a lot more, and I'm not a science person, so I won't get into it. But the question then becomes, what were the first solar observers thinking when they were observing? What were their observations and their conclusions? Well, here we go. I have made a profound conclusion in regard to the sun. What's that? It only appears during the day. You're a genius, Peter. And that's not in reference to you, Peter.
Thank you.
Not that you're not a genius, this isn't referencing you. So then, we look at solar observing, and we know that there's a correct way of observing the sun, be it through direct viewing or with some instrument of some sort, like the solar projection or whatever. We also know there's an incorrect way. We don't use naked eye, we don't use sunglasses, and we don't use photographic film. But when you're looking at caveman, they wouldn't have had any of this. So what happened when they viewed? I'll let you read it. What? Never study the sun all day, right? So now we get into the solar eclipse. Oop. So what did early humans understand? What was their comprehension of what happened when it suddenly became dark in the middle of the day, the temperatures dropped, no sound from animals, birds, or bugs? What were they thinking? What would they have thought? Was it a good omen, a bad omen? Was it punishment from the heavens? Or did they think somebody was having sort of fun with them and it had an effect and they were trying to punish someone? Well, again, BC does a beautiful job. I think the moon and the sun are going to crash. Yep, there they are. There they go. Now you've done it. So, and about the moon. I know that there were some people in this room, like me, who are really enthralled with the moon, its phases, its features, its geology. Husband's pointing to me. But maybe there were you, or maybe a family member, maybe not feel the same way you do, and perhaps feel like Garfield. Now the sun is set, we come to the exciting part. We turn around to watch the moon rise. Be still, my beating heart. And we also know that First Nations around the world, not just here in North America, but around the world, have various names for each of the full moons based on their geography, their wildlife that are around them. And they have traditional names. I mean, the two I'd seen that Dave Chapman and Kathy LeBlanc have described to our center on a couple of occasions, giving names, what the Mi'kmaq names are to the various moons. Well, I came across this cute little cartoon from Mutz, and this would have been appropriate for last month. Keeping in mind that this month is April and it's bird laying month, or bird laying eggs month. But last month, did you know the March full moon is called the worm moon? Yes. And I know the supermoon, that terminology, not many people who are astronomers appreciate that term and wonder where the devil it ever came from. It isn't really appropriate. And so this cartoon from Betty suggests that astronomers are prone to a hyperbole. However, is it really the astronomers that are prone to hyperbole? Or is it the media who like to explain things so they can draw to their articles in the newspapers? Or was it the astrologers? Well, in fact, it was an astrologer, Richard Nolan, in 1979 in a horoscope magazine, coined the phrase, and that's where it came from. So supermoon, this is just a silly look by Garfield at the supermoon. And Dave's asking, or John's asking, was there a supermoon tonight? Nope, just a goofy one. And of course, we can't forget the blue moon. And to look at the blue moon. Now, I did alter this slide slightly in that I took the words from the song Blue Moon and inserted them over what was written there because it would be more recognizable. But Blue Moon was actually a song that came out in 1934 by the Marcells. So that's where those words came from. Now, lunar eclipses. I think most of us have seen a lunar eclipse. And have you noticed stars during totality? How late have you had to stay up to watch this eclipse? Sometimes it's in the early part of the evening, sometimes it's like 1 in the morning or later. Are you willing to stay up that late? Well, Betty, I think the brightness of the moon tonight will make it hard to see any stars. You're right. As luck would have it tonight, there's a total eclipse. That's when the moon is the shadow of the earth. Actually, that sounds really interesting, provided it starts in the next 15 minutes, right? So obviously they're not willing to stay up very late for this. So leaving the moon, we're going to go into something that UFOs, unidentified flying objects. This particular term became popular after, since 1947 and during this, especially during the space age. So that term has come about. And again, Betty, it's one of my favorite cartoons because whoever writes Betty obviously knows something about astronomy because they have several cartoons about it. But this is one about UFOs. But there weren't nothing exciting tonight. We're going to go to bed, and of course, then the UFO flies by. And you want positive proof that there is such a thing as a UFO? Well, you go to John Fogerty and his song, right? It came out of the sky. And again, Betty, the son's questioning the validity of UFO or aliens visiting from outer space. And the father says, well, if John Fogerty wrote about it, it has to be so. And then there's UAPs. So it's an unexplained aerial phenomena or an unidentified anomalous phenomena. It depends upon who you talk to or what resource you're looking at. And this is a term that appeared in the 1960s, and it had to replace UFO because UFO, when people said, oh, I saw a UFO, you're going, yeah, they're a little loony, to just ignore them. So they renamed it, and now it has more validity because now they're looking at it in terms of what was that object? Right? Was it atmospheric or was it really a UFO? So again, my favorite source, Betty. While we're waiting for lunar eclipse, we might see a UAP. UAP? What's that? A UFO? Well, UAP means unexplained aerial phenomenon. So a UAP is a UFO for people who don't want to sound like crackpots. Pretty much, yes. And then we have another area of endeavor, which is the planetary science. Again, going through the years of science from time immemorial and people looking at planets and learning more and more about them, what they are, how they are. I'm not going to go into great detail here. What I am going to show you, though, is a joke, and I apologize for the people who don't like puns. Freddie Mercury, Venus Williams, and Bruno Mars walk into a bar. They didn't plan it that way. A little bit more about planetary science. Well, again, we're looking more into how planets are formed or how do they evolve. This is a picture of Jupiter. And we know that Jupiter was actually the first planet formed in our solar system, and the Earth wasn't formed until about 50, I think, million years afterwards. So that we're young relative to that particular planet. And we know that Jupiter wasn't, or Saturn rather, no, I was right the first time, Jupiter wasn't formed by asteroids, but it certainly had an effect on the asteroids and other bodies that were near it. So this cartoon, sure, Jupiter's the biggest, but I know for a fact that he used asteroids to build up his bulk, which may or may not be true. And for those of you that were here at the January meeting, you would have heard David Barron speaking about Percival Lowell and the Martian canals. And so I found this wonderful cartoon, The Other Coast, that explains perhaps the demise of the Martian water. I got a funny feeling I might have left the tap running in the kitchen sink. Right? And again, apologies to those that don't like puns. Where do aliens park their spaceships? Anyone? Next to the first available meteor. And of course, interplanetary travel. Now, this is certainly front and foremost now that Artemis, and they're talking about how the impact of this particular space flight will impact our, at some point, arriving on Mars. So when we're talking about interplanetary travel, you have to look at crew requirements. What are their number, their expertise, their sleep patterns, all sorts of health issues. Well, I guess they wouldn't have health issues if they're up in space, but what are the special requirements? The Other Coast, from a dog's perspective, of course. You know, one day we will send manned probes to explore distant planets. It would take months, even years to travel the vast distances. To survive the journey, astronauts would have to be put into sleep chambers. Right away, I see a problem. Tap, tap. What? You want to go out again? So if Artemis thinks it has waste product management issues, imagine what that would do. And then we want to look at infrastructure once we get there. What about their housing, their food, their transportation while there? Sanitation issues again. So again, the Other Coast. We can't just turn up on Mars and expect to be able to live there right away. They'll have to put infrastructure to make it habitable for humans. Well, what if they have dogs? I'm sure they'll put their own infrastructure. So comets, these wonderful interstellar objects that come flying past us from time to time. We know what they are, from whence they come, but it does make you wonder what prehistoric man may have thought about this. When they saw these, how would they explain them? Again, BC is a wonderful source for this. What's that? Kahutek, Gesundheit. So again, sorry. But then you have meteors. Now, there is a difference between comets and meteors, which I'll explain in a minute. But maybe there are times when you knew that there was a meteor shower out there and you really wanted to see it, but for some reason you just couldn't get out to see it. So what do? Well, you do like Calvin and Hobbes. Every night looks like a meteor shower if you shake your head fast enough. Right? And we do know that the general public, and sometimes some of the newbies to astronomy, get confused about the difference between a comet and a meteor, calling one the other. And so here's a little joke to help you explain the difference, perhaps, to your students or your fellow astronomers. What's the difference between a good burger and a shooting star? The burger is very meaty, but the other's a little meatier. Right? So, astronomy clothing. You'll notice down the lower left there, there's a picture of Orion, the constellation. And yeah, he's got a belt, right? Isn't that the first piece of clothing that we find or discover out in the night skies is Orion's belt, because it does several things in terms of pointing to various stars and constellations. And we figured, okay, Orion was a person at some point, or a god or whatever, and he would have got his first belt. Well, how would he have felt about that first belt? Orion, there's a package for you. Oh, my new belt. Not as good as I expected. 3 stars. So then we look at another constellation, Capricornus. Now, to me, that just looks like an upside down triangle, right? But there was a point in time, to me it looks like the smile on the theater mask. That's what I always envisioned it to be, okay? But then there was a night out at SCO when I said, Orion's what? I was a young astronomer in 2015. I mean, young as I was only a member for 2 years in RASC. And a more senior member came up to me and said, well, Jude, you've seen Orion, right? And I thought, well, yeah. He says, have you seen Orion's underpants? No. And he pointed to Capricornus. And I'm looking at it going, well, it really doesn't look like underpants. It looks more like a Speedo swimsuit, right? But then this wonderful cartoon, Zitz, may present a different perspective on what that piece of, or what that constellation looks like. Stargazing? Yeah. Have a seat, Dad. When you were little, we used to do this all the time. I still remember the names of the constellations you taught me. You know that I was just messing with you, right? Yeah, I always thought Orion's fanny pack sounded quirky. So, and what I found really intriguing about this cartoon was not only that, it wasn't just Orion's underpants, but now his fanny pack. But also, did you notice the constellation in that one segment? It's either, I figured it was either the Little Dipper or his Delphinus, right? From the look of it. And about weather. Well, we all know about those sucker holes. It's ever the optimist, right? You hope against hope that will open up and expose. And you notice all the different types of telescopes that are out in that observing field? I thought that was rather cool. Oh, and by the way, that picture that's in the background was taken out at Grasslands National Park by us. That was the storm that was approaching us that one time when we were there. Thankfully, it didn't last long, but trust me, it was scary when it did hit. And then with the family circus, they always put a different spin on things. And in this little kid, I thought it was a really neat way to describe a cloudy day. It's a gray day, not a sky in the clouds, right? But then we have her brother, and he doesn't think of it quite the same way. Who invented clouds? Right, because he's frustrated, he can't see squat. But we know the real reason that there's cloudy skies, right? Is who bought equipment? And once you have that equipment, you want to make sure that it's clean all the time, right? And that's Halley searching for his comet. In case you can't read the bottom. And if you don't clean your equipment, this sort of thing can happen, right? Where, good news, the asteroid on a collision course with Earth disappeared when they dusted the telescope. So how many of us have been out there and thought we saw things and actually it was a fleck of dust or whatever across our screen? I did that when observing the moon, one of the moon craters one time on high resolution, and I thought, oh wow, look at that rill, and then realized later, no, there is no rill, that's a piece of dust. So it can be frustrating. And we look at Artemis, and I know this slide is not humorous, but it certainly gave us some oh wow moments with the solar eclipse, the Earthrise, the moonshine, not Earthshine, but moonshine. And for me, the Mare Orientale, when they went past it, I was glued. They had me right there, could not leave it. Just an incredible thing. And to think that that's 600 miles across. But anyways, I won't get into that one. But there, one of the phrases that came up when they were going around the moon was the phrase moon joy. And it refers to the excitement about seeing what's on the moon, typically by being there as an astronaut. So the humor in this, let's go to Michael DeAtter. With Pink Floyd in Dark Side of the Moon album. And so, do we need humor? Sure we do. It reinforces that known knowledge. It helps remember new information. Laughter is medicine after all. It gives a social connection and makes learning fun. And I apologize for the pun again, but I'm at the end of my Europa. So thank you for being patient with me and for listening, and hopefully you had a bit of a chuckle, if not a full-blown laugh. And don't forget, laugh hard, laugh loud, and laugh often. And most importantly, don't forget to look up. The skies are open. So with that, I think I will hand it over to Paul Heath, who's going to address suns in the moon, or suns in the room. Oh, yes, you need this, don't you? There you go, sir.
You hear me? Up. One of the big issues I had trying to teach this to grade 7 and 8s was perspective. A lot of times, as you can see on the slide, it might, very few people actually can visualize from a graphic. So when I first started this, I started with styrofoam balls, and I could never get anything much bigger than 3 or 4 inches across, and it really didn't give the proper perspective. A couple years ago, the party store started selling the balloons that expand to 2.5 feet. So that gave me the opportunity to give a more accurate perspective of the various star types. So when you're going through the star classifications, I usually start with the red dwarf, which is the smallest, but it can also be the largest, as Betelgeuse is a super red giant, and it's also an M-class star. And then K stars are orange. So we've got our red dwarf, our K star, which is slightly smaller than our sun. We've got a G class, which is our sun, and the F class. These are all main sequence stars. Basically, G example is the sun, K star Arcturus, Proxima Centauri for a red dwarf, and of course Betelgeuse for the supergiant, and the F star Procyon. So you've got your basic main sequence stars that aren't fairly close to the size of the sun. So they're easy to do with just regular balloons. And you can, by putting a red balloon inside a yellow balloon, you can get an orange balloon. So you can, with the inflation, you can get the different colors requirements. Now, when we get to the next size up, to the A stars, A class, which is just on the edge of the main sequence, you need the larger balloons to be able to do that, because the A class is about 1.5 to 2 times the size of the sun. The B class stars, temperature range 10,000 to 30,000 degrees, and they're generally a blue-white in color, but to be accurate for this scale, this balloon should be about 8 times bigger, and with the O type, it should be 50 times bigger. So they won't fit through the door, so I have to go with this size here when we're moving, and they just fit in my car. So,
The door didn't open much farther. So with the 2-foot balloons, you can actually get a fairly good grasp of the difference between our sun and the larger stars. There's our sun, and there's the A, B, and O type stars. Now the blue supergiants, an example is Alnitak, which is one of the stars in Orion, and Rigel is our blue B class, and Sirius is a prime example of an A class star. But what I like about these is that the balloons generally stay full for a couple of weeks, long enough for the teachers to, because I never bring these back with me. Is there any teachers here that need presentation material? Because hard to get back in there. But they can stay in the classroom and give the kids a chance to really examine them so far as the size difference and the color variations caused. And the color is caused by the temperature of the star, of course. Now, the other thing with the stars is perspective. Now, why would we need to know why the stars are different sizes? Some of the stars we see, Orion is a prime example. Some of the brightest stars in the sky in the wintertime, but they look like, oh, they're all in the same place, but they're not. The three-dimensional image shows that they're stretched quite a ways away from each other. And when we go to the actual how far apart they are, Betelgeuse is 243 light years away, Betelgeuse 643, Cepheid is 724, Alnitak is 800, Rigel is 850, Mintaka is 900, and where am I got? Alnitak is 1359, and the nebula, depending on what you're going, some people think the nebula is closer than Alnitak, and some people think it's farther away. It depends on the source. This is from the Hippocrates. Am I pronouncing that right? Hipparchos information. But getting them to realize that this star, Rigel, is so bright because it's so big. And even though it's 643 light years, or it's 850 light years away, it still looks brighter than some of the stars closest to us, a lot brighter than our star. So when we're trying to show perspective, having them be able to see the size difference in the stars really gives a better grasp for the students when they're trying to learn the classifications of the stars and why they look like they do. Because Betelgeuse is super red giant, which is fairly good size. And there again, like I was saying, that should be another 50 times bigger in size to be accurate to the scale for our sun. But I love the fact that you can get the large balloons now, and we can demonstrate actual size differences when we're in the classroom. So we can take these in and give the students an actual visual representation. Also, when you're looking at the stars, you can start with the sun, just basically a regular balloon blowing up to almost a foot in diameter, and it takes about a month for them to sag down, so they'll last for a while. But when we're going for a lot of questions in star, well, what happens, like white dwarfs, what happens to our sun? We're at about 4 billion years of age right now, and if we wait another 4 or 5, it starts to stretch out. Could I get a volunteer for a second? So basically, what I've got here is each 6 inches is 1 million kilometers. So as our sun gets older, we start to expand. Where this is what us right now at about 4 billion years. And in about another 8 billion years, our room's not big enough. We're outside the door. That's how big we are. So basically roughly out to the orbit of Saturn. So this basically fills most classrooms. And then when you tell them once this all drifts away, because gravity won't hold it when it expands, we're left with a white dwarf about the size of the Earth. Yet it still retains half the mass of our original sun. So half the mass of our sun is contained in a size, this size, about the size of the Earth. So you've got a fairly good grasp of perspective, and it makes for some interesting conversations. But generally, it's fairly easy to do. I would recommend a electric pump. Hand pump takes 25 minutes to blow this to blow up Betelgeuse. So electric pump for blowing up the balloons would probably be a good idea. But as you can see, it really gives a visual grasp for the students when they're looking at the various sizes. And then you can show them why the stars are so bright, even though they're so far away. Because the size, you can relate the size to how far they are, and the fact that because they're so big, they're visible and very bright in the night sky. So it's a fun little exercise, and it keeps you busy in the afternoon when you run out of wine. But I don't. Is there any questions? It's it's fairly straightforward. I just thought I've spent. Yeah, was there a question?
Just a solution for transporting Betelgeuse with your dog. A pinprick would demonstrate how there's a type 2 supernova.
Yes, that is true. The only problem is I don't have my earplugs with me because I need those when she goes. That just fit in my car. I just got the door open enough to be able to get it without opening the trunk. So, but yes.
Back in the day when I used to do this stuff, I did do supernova simulations, and I used to fill the balloon with glitter. And then it was nice to clean up, but that wasn't my problem.
Well, yeah, I have that when I do the moon crater demo. I usually leave the mess for the teacher because I ask them for a tarp to put down first, and if they don't have one, well, the powder tends to go all over the place. But you can have a good time with this so far as demonstrating the size. And when the kids at Port Williams realized that this could be 50 times bigger, and we measured, basically it would fill the whole classroom. So the model itself would be the full size of the classroom. That really gives the kids a grasp of how big is big. So it's only been a couple of years since I've seen the balloons this big. I'm waiting for the 3-foot balloons, and I can really do something with those. So, but I guess that's about all I have. So, so is there anyone that needs a class project?
Outreach opportunities. There's the Halifax Center is going to have a table and display at the Discovery Center on the 25th of April. If the weather is good, we'll have solar observing outside of the main door, and in the evening we'll have some telescopes on the boardwalk behind the Discovery Center to grab members of the public as they come by. That's the only outreach event that I'm aware of that's coming up right now. We're planning to do another kind of pop-up outreach at Harry DeWolf Park at some point. I guess now it would be sometime in May, and we'll stay tuned. We'll pick, because by May it's going to be quite late before it gets dark. We'll probably pick a day when the moon will still be visible, and we'll kind of focus on looking at lunar craters. Now, a bit of an announcement in terms of observing. The center got an email from Tom Calderwood, who is affiliated with the American Association of Variable Star Observers. And they have a citizen science project that they were looking for participation from either someone in our group or someone we know. I know that a couple of the kids at Parkview Education Center are interested in this. The project involves using photometers to measure changes in the brightness of Alpha Cygni variable stars. And if anyone's interested, email me at observing at halifax.rasc.ca, and I'll pass on the contact information to you. Basically, they're looking for someone, kind of minimum equipment would be a 8-inch Schmidt-Cassegrain or a 5-inch short focus or a wide field refractor. And they have some loaner photometers that are available if for those that don't have them. And the caveat is that the telescopes would need to be set up for extended periods. Okay, so this would be good for someone with an observatory, for example, where they can leave their telescope set up. But anyway, if anyone has an interest in that, drop me an email and I'll pass on the contact information. Now we have update from the board with Tony.
There's a couple of things I'd like to just bring to your attention. Specifically, this year we tried to do a couple of things with respect to getting some more members engaged. Some more members engaged in the center? Outside voice. Okay, so we're specifically trying to get some more members involved in the center activities. So there's a couple of opportunities that have come up. These are just one-time opportunities, no big commitment, just, maybe 4 or 5 hours, 6 hours worth of work. One of them is associated with the St. Croix Observatory inventory report. The inventory's been done, a bunch of arithmetic's been done, but we need to sort of summarize it so I can present it to the board. And I was looking for somebody who might be able to give me a hand to put all that data, to reduce that data down to something that we can present to the board. A couple hours of work, perhaps. So if there's anybody, thank you. Frank, you don't have to volunteer right now. You can always let me know later on. So I don't want to put anybody on the spot. We're coming up to the end of our year in December, of course. So I'd also encourage folks to think about opportunities for shadowing. If you're interested in things that the center does, for example, outreach, if you're interested in outreach, then, good opportunity to shadow folks like, David or Peter or Tony and see what some of the things that they're doing and just get a sort of a sense for what that is. And maybe you might have some interest in pursuing some of those kind of activities. So, give that some thought. You may, or a board of directors. You want to know what the board of directors does. You come on and hang around with a director or with some of the members of the board and see what actually entails to work on those things. And always for presentations during the monthly meeting, if you've got something of interest, it's always great fun to get up and deliver a presentation about something you're interested in. Just wanted to update folks, the David Lane Memorial Scope Fund is at $25,170, which is fabulous. While the matching dollar campaign is concluded, you can still contribute to the fund, and the details for that are on our website. The Astro photo sale is still underway. I would encourage folks, go have a look at the website and go look at some of these. Those images are just stunning, some of those, just beautiful. So go have a look. And, there's a selection there of wide field shots and some deep space objects. So go have a look. Just beautiful photography, beautiful imaging. And these photos change from time to time. So you come back and have a look. Nova Notes, the current edition is the January-February edition. Lots of interesting stuff in that. That's an amazing presentation. I don't know if everyone feels the same way as I do about it, but it's just amazing to have that as part of our center. I mean, Lisa Ann Fanning and John McPhee do a tremendous job. It's just a wonderful, wonderful document, and we're very lucky to have it. This current issue is full with all kinds of interesting things, so I'd encourage you to have a look at that. Blair has written up the results of a successful experiment to determine if it was possible to observe the transit of exoplanets across its parent star from your driveway. And it's a fascinating read. It's a beautiful example of citizen science. I struggle to get the internet in my driveway, and Blair's out there observing exoplanet transits. I think that's amazing. Mare Orientale, David has which is a spectacular lunar feature, and Judy mentioned in her presentation. David has an article in there as well with some tremendous amount of information about, some techniques you can use to observe that. So if you're interested in seeing that object, very much have a read of what David's done there. It'll save you a tremendous amount of time and get you oriented correctly. There's a couple of poems from our poet laureate of the center, and as well, an addition to the archives of the predecessor to Nova Notes, which was Galaxy, which was published in 1960, 61, and 62, which I had never heard of until just recently. And we came by that courtesy of Michelle Lane, who donated some of Dave's papers. And in those papers, there were copies of those issues. So, and if your brain is in need of a little workout, Lisa's Puzzle Corner is there. Spring is coming. It's a lot of fun, so have a look at that. Couple of big events coming up in the summer, of course. We've got the deadline for submissions. The deadline for submissions for the next Nova Notes is April 18th. So if you've got submissions to Lisa Ann.
The night of the new moon.
A couple of, you think about summer's coming. We're into the season of, so the Dark Sky Weekend is at Kejimkujik National Park and Historic Site. That's August 7th to the 9th. If you're interested in volunteering, you can contact Peter Hurley. The information's on the website. Or Tony Shelnick. If you want to have, if you're using an RV or a camper or something, you have to get a site through the park, I think. Is that correct, Judy? Yeah. Or if you want to have a fire or something at night, you have to go through the national park system and get a site. Nova East is scheduled this year for August 12th to the 15th, the following weekend from Dark Sky, KG Dark Sky weekend. This year, we've got a bit of an interesting program. We're going to start a day early with, and Paul Gray is going to have a short session on August the 12th about observing meteor showers. The Perseids are going to peak, I think, that time, Paul. So we'll do a presentation, and then over the course of that following nights, we'll do some observing. Again, with respect to with Nova East, if you want to camp or have a fire, you have to get a site not through us, but through the Nova Scotia Park system. RASC Awards, the website, of course. I encourage everyone to have a look at the website. There's a number of awards. The deadline for submission is the end of December. Again, on the national website, there's observing certificates, so visual observing certificates, as well as astro imaging certificates, and the requirements for those are available on the website. The next meeting for the Board of Directors is the 2nd of May. If you have any issues or concerns or items that you want to address to the board, let me know or let any board member know. Our contact information is on our website. RASC National Council has their next meeting on April 26th, and the National Council, as you may know, is an advisory board to the National Board of Directors, and is the mechanism through which the centers really have an opportunity to communicate with the National Board of Directors. Our National Council representative is Judy Black. The week of April 13th to the 20th is International Dark Sky Week. The new moon actually occurs on the 17th of April, and so that's a regularly scheduled St. Croix Observatory observing night. So we're going to have weather permitting, of course, we'll be at St. Croix, and so we encourage everyone who's able to join us. There'll be more information to come via the list. The RASC General Assembly is also scheduled for May the 2nd this year. This is an online event. Information again is on the national website, and you can register to attend there. The Canadian Space Agency, their Manager of Science, Astronomy and Planetary Exploration Missions, Mr. Pierre Langlois, will be addressing the RASC Kitchener-Waterloo Centre. And thanks to the efforts of our Frank Logan, we've been invited to participate as well. So it's a wonderful opportunity. It's going to be an online presentation. So keep your eye on the list. There will be information circulated about how you can participate. Upcoming public meeting dates, we have the May 9th. Chris Gaynor from Victoria Centre is going to be presenting. The topic is how engineers from Avro, Canada helped put astronauts on the moon. And on June the 6th is the meeting, follow-on meeting for that one. The David Lane Astronomy Outreach Program at St. Mary's University. We'll have someone here to tell us about the outreach program. We're still working on September and October speakers, but we do have Blair scheduled for the 7th of November to tell us more about his exploits in the driveway and exoplanets, so we'll look forward to that. And of course, in December the 5th is the annual general meeting coming up. Okay, all right, thank you. So with that, ladies and gentlemen, thank you for your time and attention. And David?
Okay, so we're going to finish off with what's up in the April sky. Good, it's working. We just had the spring equinox, so which was March 20th. So now the days are getting longer than the nights. So by the end of April, sunset will not be until 8:17, and sunrise will be at 6:05. So imagers, you'll have to stay up later to benefit from any dark skies. The sun's fairly quiet this week. We've had some active sunspots, one of which was giving some M-class solar flares, but they're receding the western limb of the sun. And we've got a couple sunspots coming into view, but their magnetic fields are so far quite stable, so not likely to get any solar flares in the immediate future. Full moon, we had that on the 2nd. That was the maple sugar moon, and hopefully some people saw, I don't know if we had clear skies or not, probably not, the week before this. The new moon is on the 17th, and that's Birds Laying Eggs moon. And then there's a whole bunch of interesting things happening with the moon. On the 18th, the moon's going to be near Venus. On the 19th, near the Pleiades. The 22nd, near Jupiter. On the 23rd, near the Beehive cluster. And then the first quarter moon on the 24th, followed by the moon being near Regulus and then near Spica. I won't dwell on this because it's past history. On the 18th, so if you've got a good western horizon, you'll be able to catch the Venus and the very thin crescent of the new moon. So that's something to have a look at if you've got.
What date is that again?
Pardon?
When is that again?
The 18th at 8:30 p.m. So you don't need to stay up late. So if you got a good horizon, see if you can catch. Venus is going to be very bright compared to that slim crescent. And on the 19th, with binoculars, again, a very thin crescent moon in close proximity to the Pleiades. So that should be a nice sight through binoculars. And if you're an imager, you could catch the thin crescent and the Pleiades with a telescope such as a Red Cat 51, which is about a 250 millimeter focal length, and an APS-C sensor. On the 22nd, the moon will be near Jupiter. Again, it's the moon's disk is still going to be fairly small. It's going to be a waxing crescent. So Jupiter should show up nicely in comparison to that moon. And then on the 23rd, where we're near first quarter, there's the moon and the Beehive cluster. Again, looking quite nice. The 25th, the waxing gibbous moon will be close to Regulus, and notice that Regulus is a double star. So that's always, Regulus is really bright in binoculars, and with this 15 by 70s, which are the Celestron Sky Masters, so you'll be able to split Regulus and enjoy the features of the moon. And then at the end of the month, the moon and Spica, the brightest star in Virgo, will be visible in 7 by 50 binoculars. Best time to look at lunar features that are required observing for Explore the Universe certificate is around the time of the first quarter moon. So April 22nd to the 26th. And the planets. Mercury is currently very low in the east before sunrise. That's a typo, it should be mid-April. Conjunction with Mars and Saturn on the 19th. Venus is very prominent in the west after sunset. The sun's going down. If you look in the west, you can't miss Venus. It's a brilliant beacon. Near the waxing crescent moon on the 19th and near M45 at the end of the month. Mars is very low in the pre-dawn sky by the end of April. It's the start of the month. It's pretty much lost in the glare of the rising sun. Jupiter's still visible after sunset, high in the east. easy to find in the night sky. Look directly overhead pretty much, and the brightest thing you see will be Jupiter. Saturn is now very low in the pre-dawn sky by the end of the month. There's a conjunction with Venus. Boy, I wasn't paying much attention in my cut and paste here in terms of the dates. And Uranus is still in Taurus after sunset, but by the end of April, it'll be too low to observe. And Neptune's lost in the pre-dawn twilight. So this is kind of a fun one. April 24th, if it's clear, just after sunset, so pretty low in the west, you'll be able to, in 7x50 binoculars, you'll be able to see the Seven Sisters, the Pleiades, Venus, and as a bonus, Uranus in the same field of view. And for imagers, if you've got a lens with a focal length of about 100 millimeters and an APS-C sensor, you'll be able to catch the whole thing nicely framed. This is your challenge for April. This is a conjunction of Mars, Saturn, and Mercury. You see how low they are. You'll need a really good eastern horizon. I think if you go down to one of the beaches, at Peggy's Cove or something like that, we were looking over the ocean. But this is, my gosh, I made a mess with the times of these things. That's April 30th in the morning. Okay, so Mars, Saturn, and Mercury. What else is coming up? Meteor showers. The Lyrids are coming up on the 22nd. The peak is predicted to be at 2 a.m. Atlantic Standard Time, so you have to stay up really late. The good thing is that the moon is setting before midnight, so anytime after midnight will be a good time to have dark skies, to look up at, see if you can see any of these meteors. The radiant, as the name suggests, is in the constellation Lyra, shown here. And typically, this particular meteor shower gives us 10 to 15 meteors per hour, but it's possible to have bursts of up to 100 meteors per hour, and fireballs are possible. So worth looking up if the sky's clear and you're up around midnight or after midnight. The apparent object for this particular meteor shower is comet C 1861 G1. Spring constellations for Explore the Universe: Ursa Major, Ursa Minor, Bootes, Leo, Virgo, and Libra. So those are what you need to identify. And spring stars, brightest is Arcturus, and Spica, Regulus, Dubhe, Polaris are the brightest 5 stars in those that spring ranking, and pretty far up from the horizon, so pretty easy to find. Deep sky object is the Coma star cluster, Melot 111, also known as Colander 256. It's an easy one to find. Find the sickle of Leo and look to the left, and you'll see an open triangle. And the star cluster is directly south of Gamma Coma Berenices, which is a 4.4 magnitude star, so which is right there and shown here, and there's the star cluster. Okay, so really nice and a nice deep sky object in binoculars. It's a fairly widely scattered star cluster. It's not particularly rich, but very nice to view. Anyone that's out at SCO for the next viewing night on the 17th, that's a good target to have a look for. Double stars. The double star for April is Mizar and Alcor. So that's an easy split with binoculars. Mizar is a second magnitude middle star in the handle of the Big Dipper, right there. And if you've got really good eyes, so if you're younger than most of us in this audience, you might be able to split it with the unaided eye. Otherwise, you'll need binoculars. The interesting thing about if you have a telescope and you split this star, you'll be able to see that Mizar actually has a companion, and that'll see that here. And there's Alcor, which is a fourth magnitude star. In total, the Mizar-Alcor pair is a 6-star system. And then there's another star shown here, Sidus Ludoviciana, which is an 8th magnitude star, so you'll only see that with a telescope, and it lies between Mizar and Alcor, but it's not related to them. It's not part of the 6-star system. And that's it for the April skies. Any questions? Okay, thanks. If there's no questions, hope to see you all next month. And remember, if you have time, on the 25th of April, drop by the Discovery Center and give us a hand with the public displays. Okay, thanks everyone.